This is a lab on the preparation of alum. And we'll walk through that and then show the experiment. An alum is a hydrated double salt, which means it has two metal atoms of different types, and they're usually a +1 and a +3, so the metals are different. And then we got two sulfate ions, and then our particular atom has 12 waters of hydration that we're going to make. But the M plus is usually an alkali metal, sodium, potassium, or polyatomic ammonia, or it could be silver even. The 3 plus ion, the trivalent ions, in our case is going to be aluminum, but it could be iron or chromium or titanium or cobalt, something with a +3 plus charge. And we're going to make potassium alum, which is potassium aluminum sulfate dodecahydrate. And it's made usually water purification. It can be used as a pickling agent to make pickles. It's found in commercial deodorants because it inhibits bacteria growth and consequently you don't smell bad. The potassium aluminum sulfate dodecahydrate, or the potassium alum, is prepared from aluminum and potassium hydroxide. The aluminum metal rapidly reacts with the aqueous potassium hydroxide, which tends to heat up, gets hot, produces hydrogen gas, which if you're doing this experiment and not just watching the video, that gas is flammable, so no open flames. And then but what we end up forming, if you look at that reaction below, is an aluminum with 4 hydroxides, so it's not stoichiometric, and it carries a -1 charge. That happens to be water soluble, where normal aluminum hydroxide is not. We're going to use that to our advantage. We're going to treat that with sulfuric acid until the aluminum hydroxide precipitates, but then we're going to dissolve it with heat. Don't add so much acid as to dissolve that aluminum hydroxide, or you get an aluminum ion that's too tightly bound with water to form our precipitate. So you form the aluminum hydroxide in that first step, and then when we add the acid, we're going to get the aluminum ion in solution, the sulfate, and 6 waters of hydration. And we need that. So now we've got all 3 things. We need the potassium, the aluminum, and the sulfate. And then we're going to heat that precipitate until it dissolves. And then we'll form our product. And so all of those come together to form our potassium aluminum sulfate dodecahydrate. When you're doing your calculations, I know we're doing several sequential reactions, but the aluminum to alum ratio is a 1-to-1 proportion for your stoichiometry. And we'll take its melting point, and it should melt in the 92 to 93 range. Okay, we're going to start by adding about 1 gram of aluminum, or weighing that out, and before we add it to our reaction, we're going to close that so that we can eliminate drafts. And so we've got 1.009 grams of aluminum for our reaction. Now to that aluminum that we weighed out, and I put it in a 150 milliliter beaker, we're going to add 25 milliliters of potassium hydroxide. You want to be cautious because that is caustic. Make sure you're wearing your gloves and your eye protection. This is 4 molar potassium hydroxide. We're going to add it to the aluminum, and it's going to begin to react. And you'll have to manage that a little bit as it does. Make sure all the aluminum gets down into the eventual solution. But the aluminum will begin to react, and it will bubble and fizz, and it will release hydrogen gas. You want to make sure there's no open flames or any ignition sources, because that gas is flammable. And it will take several minutes to react. But you can see there at the bottom that it's already starting to bubble and fizz. And so we'll come back in a few minutes and see how it's doing. And you can see eventually the reaction will pick up and it'll look a little bit more vigorous like this. But you need to wait for that fizzing to stop. Okay, now the solution's been filtered. You can see it's a lot clearer than it was. Now to that solution we're going to add some 6 molar sulfuric acid. Right now this solution is highly alkaline, and so the aluminum that we added is in the form of AlOH4-, which is not stoichiometric, but because of the excess of hydroxide in the solution it's stable and water soluble. When we add the acid, we're adding the sulfate that our reaction needs, because we already got the aluminum in there. We added potassium hydroxide, which gives us the potassium. Now we're going to add the sulfuric acid, which will get us in the right pH range, because we want to precipitate out our aluminum hydroxide, and adds the sulfate ion at the same time. Be careful, because if you add too much, the pH goes too low. Instead of getting AlOH3 to precipitate, the precipitate will redissolve, form aluminum ion in solution, and the aluminum is too tightly bound with the water and you won't get your product. So be careful as you add. So you're going to do so slowly. You can see I'm forming precipitate there. And so I've added my 25 milliliters, and you can see I formed a nice white precipitate. Okay, now we're going to use our hot plate to heat that. We want all of that precipitate to dissolve. It will take a while, stir, but we're going to need to take a while to get that to heat. So we're going to turn on the heat, keep it below boiling. 90 degrees or so would be sufficient. And this one has an internal temperature, but otherwise you can use a thermometer, but don't stir with your thermometer. And then we're going to heat that and mix. Heat that and mix. So we're going to take our glass stirring rod and we're going to mix that in a little bit, break that precipitate up. And then this is going to take a while, and so we'll time lapse this video just a little bit for you, because there's no point in you sitting here watching it heat. But we're going to heat and mix, heat and mix, heat and mix. Okay, we finally heated it long enough, and all of that aluminum hydroxide has dissolved. You can see it looks more or less like water. What I'm going to do is I'm going to take that off the heat, let it cool for a few minutes before we put it in our ice bath. Okay, now that we've allowed that to cool for a few minutes, we're going to take that and stick it in our ice bath, and we're going to have to wait, maybe 15-20 minutes for that precipitate to fully form. We're going to take it and we're going to set it in our ice bath. Okay, the next step is going to be our vacuum filtration. We're going to put our alum that we formed into the top of the funnel flask, and we're going to turn, that flask is connected to the sink with a hose. When we turn on the water in the sink, that generates suction that will help us filter faster and more effectively. So I'm going to turn on the water, and we're going to come in and we're going to add our product from the beaker, and we can use a glass stirring rod with a rubber policeman to help us get the solid out. So we're going to pour it on through, and I'm going to use that rubber policeman to encourage all that precipitate to go down into the beaker. We want to make sure we get it all, or it will affect our theoretical or percent yield.
because we're going to compare that to our theoretical yield once we can get this precipitate filtered and dried. You can see there's still a little bit on the beaker and a little bit on the stern rod. You can get some water, sort of squirt in there, wash the rest out. Alum can be hard to clean, so get it out while everything's wet, and that will also help with our yield. And that water will just filter on through. And then you're going to allow that to vacuum filter for a while to make sure we get all of the liquid out. And I'm going to let that run for a few minutes and we'll time lapse it a little bit for you. Okay, now that we're been filtering for a while, and we're going to wash this precipitate with a little 50-50 alcohol water. And we'll let that go through, and then I'm going to do it one more time. All the precipitate is catching on the paper nicely. I don't see any in the bottom of the flask. Let me go ahead and wash it one more time. Sometimes alcohol evaporates a little bit more quickly, and it'll help our precipitate dry a little bit more quickly if there's less water to start with. The water will go through, and the alcohol hopefully will evaporate quickly. And we'll give that a chance to filter and dry. We'll set that aside in a few minutes. Okay, now we're going to take out that alum and we're going to put it on our watch glass to dry. So we're going to pull off the top and we're just going to scrape it out. And so we're going to come over to the side a little. And so then we're going to scrape that alum out and onto the watch glass, and then make sure you catch any solid that's on the inside and scrape that on to the watch glass. And then we're going to set that aside to dry. So we're going to get the mass of our filter paper in our watch glass, and we'll need to subtract those masses from our mass of our alum at the end. So the filter paper has a mass of 0.702 or 0.01. It's fluctuating back and forth. And now the watch glass has a mass of 52.579, and we'll want to subtract both of those. Now we're going to get the mass of our alum, and you can see it's 61.541, but then we have to subtract the mass of the watch glass and the filter paper to get the actual mass. So now we're going to measure the melting point of our alum crystals. We're going to use a melting point capillary, just like an ordinary capillary tube, except it's sealed on one end. And it looks like this. We're going to tap our open end into there to get some solid into the tube, and then we're going to tap, tap, tap on the table to make it settle down to the bottom. Once it's settled down to the bottom, then we're going to put it in our melting point apparatus. This is our melting point apparatus. You're going to look through this peephole to watch when your sample melts, and you're going to set the temperature ramp here. We know that our alum melts 92, 93 degrees, and so we're going to set our plateau. So if we hold down the plateau set, we're going to get that all the way up to about 93 degrees. If it's impure, it'll melt low. So then, right now it's 21 degrees, and we're going to ramp it up. So we're going to insert that into the side, like so they can see it in the peephole, and then I'm going to hit start, and it's going to start heating. And again, We'll time lapse that a little bit. Make sure that you can see it's starting to increase, and we're going to heat it up and watch it until it melts. So we can see we're at about 67, 68, and it's continuing to increase, but we still haven't seen it melt. So we can see that it melted at about 92 degrees Celsius. So it melted at 92, and now it's